Good morning, Trig. Let's cut to the chase. So we've got all this analytical stuff. We've got all this vocabulary, amplitude and period. And what does it mean? How can I graph this? The whole point of this section 4.5 is graphing and working with graphs for sine and cosine. So there's three things I want us to focus on. For the next slide for a second, we're going to do three things. We want to be able to find the period from the equation. We want to be able to break the period up into those key numbers, those key values, the cardinal directions, because we're really good at finding the sine of pi or the sine of pi over 2. Not so much the sine of pi over 12 and weird ones. We want those cardinal directions. So that's the second one. And then the third one is plugging those values in. So we're going to handle those three things. I'll do a little bit of notes over here, and then we'll kind of see how this applies. How can I graph this? Here's an equation. Graph it. Graph one period of it. And this is how we do it, okay? So let's check it out. Okay, so here's the problem we're looking at. We want to sketch one period of 12 times the sine of 2x plus 1. Through notes and things, I think we've already done like the basic one, hopefully at this point. If not, that's okay. Then they're all kind of the basic one. They're all kind of the same. So to do this, the first thing I said when we're doing this, one of the first goal is find the period. From our little bit of Desmos introduction and discovery, hopefully you guys got this, was one of the formulas. To find the period, it's always going to be 2 pi over b. B now is this number that's always attached to the x, what's in front of the x. Maybe we're adding something to the x, and that's the c value, but whatever we're multiplying to the x, that's our b value. So it's 2 pi over b, which is 2 pi over 2. 2 pi over 2 is pi. Finding the period, piece of cake, whether from a graph, you just did that slide, or from an equation. Next, the second thing I did on my fingers, the first one was finding the period. Second one was breaking that up into fourths. Finding the key values is actually what I called it. But to do that, we need to break that into fourths. If you think about going around the circle one time, those key values lie at the fourth spot. A fourth of the 360, 90. 2/4 or a half was 180. 3/4, 270. And then all the way 4/4 was 2 pi or 360. So whatever our period happens to be for our specific example, whatever problem we're doing, we want to break that into fourths. That will always put us on the key values, and I'll show you how it works in a second. Okay. As a little side note, yes, there's different ways to break things up into fourths, but this is what I do in my head, and when we do problems, this is what I will say. We want to take whatever the period is and cut it in half. Then we want to take whatever that is and cut it in half. Then we want to take whatever that is and give me 3 of those. Okay. Normally I have notes prepared, and I have plenty of notes prepared, but I thought maybe it would be more beneficial if I drew these as we go. So I'm going to make a table where we're trying to find those key values. I have my x, and I have my y. We're going to start at 0 on all of these. That's where the circle starts. And then whatever the period is, that goes at the end, because that's when it's going to start to repeat itself. So we're going to take it from 0 to pi. Now halfway in between those is the half of that thing. What is halfway between 0 and pi? Well, that's pi over 2. Okay? Then I'm going to do it again. What's halfway between 0 and pi over 2? That's pi over 4. Okay, we're just cutting them in half. Then finally, the 3 of those. I want 1 pi over 4. This would be 2 pi over 4. And this blank spot is for 3 pi over 4. Okay? And we've effectively just broken up the period, which was pi, into fourths. Okay? So I have my fourths. The third finger, the third goal for us was to plug these in one at a time. So the actual function was y equals 12 sine of 2x plus 1. Okay, and we're plugging in these values in for x and seeing what the y value is. Once we have the y values, we plot the dots, and it should look like a sine and cosine curve, the wavy thing with nodes and antinodes, all of that. Okay, now if you're looking at these numbers already kind of perplexed with what I've been saying, wait a second, Mr. Edwards, pi over 4? Well, the sine of pi over 4 is square root of 2 over 2. That's not one of those key features. And I get that. That's because before we take the sine of these things, we're timesing it by 2. We've changed the period. So let's go ahead and start with the first one. I'm going to plug in a 0. I'm going to take 2 times 0, and I get 0. Awesome. So now this becomes 12 sine of 0 plus 1. Okay. Well, the sine of 0, we should be getting good at these. Sine of 0 is 0. 0 times 12, 0. 0 plus 1, 1. So when I plugged in a 0, I ripped it through all the trigonometry and arithmetic, and it kicked out a 1. The next one is pi over 4. So we're going to do 12 sine of 2 times pi over 4 plus 1. Okay. 2 times pi over 4. 2 times pi over 4 is pi over 2. Ooh, I know that one. That's 90 degrees. The sine of 90 degrees, the sine of pi over 2 is 1. 1 times 12 is 12. 12 plus 1 is 13. And we're going. Okay, eventually you guys are going to get to the spot where you can just from these two and kind of how the equation works, you'll be able to figure it out. But let's keep going for now, since this is one of our first ones. The next one, 12 sine of 2 times, what are we plugging in? Pi over 2 this time, plus 1. 2 times pi over 2 is just pi. That's 180 degrees. The sine of 180 degrees, the sine of pi, is 0. Times 12 is 0. Plus 1 is 1. Okay. Next one, 12 sine 2 times 3 pi over 4 plus 1. 2 times 3 pi over 4 is 3 pi over 2. That's 270 degrees. That's the bottom of my circle. The sine of 3 pi over 2 is negative 1. Negative 1 times 12 is negative 12. Negative 12 plus 1 is negative 11. Last one. 12 sine of 2 times pi plus 1. Well, no canceling out here. That's just 2 pi. 2 times pi is 2 pi. The sine of 2 pi is 0. 0 plus 1, 1. Okay, and these are always going to work like that, all right? We've seen some generalizations here with all these sine. A sine that hasn't been, well, in general, sine is always going to start from a node. It's going to go up to a maximum. Then it's going to bounce down, right back down to the node. Then a minimum, then right back down to the node. Then the next one, maximum, node, minimum, node. And it's just going to keep going like that and keep repeating itself. But this is one period. We have one period. So we have one thing left to do. Sketch a graph of it. We have our points, so let's do that. Okay, let's change colors here. We can make this colorful, right? So, same kind of thing without a table. Ooh, it's not as neat as I would like, but we're going to deal with it. Sometimes Mr. Edwards' OCD gets the best of him here. I really want this to look straight, but that's okay. We're going from 0 to pi. Half of that was pi over 2. Half of that was pi over 4. And then 3 of those, 1 pi over 4, 2 pi over 4, 3 pi over 4 is right here. There's the fourths I was talking about. At 0, we went up to 1. At pi over 4, we went up to, let's just call this 13. At pi over 2, it was at 1. At 3 pi over 4, it's at negative 11, right in the middle of that thing. And then at pi, it's back at 1. Okay. The final part of this is just to connect these with a smooth curve, not a sawtooth. It's flat at the tops of these things. At the antinodes, it's flat. And then it's at its steepest at these nodes. So you're going to have to work with some concavity as a word you'll use in calc. But for now, something like that. Okay, I'm not going to be super picky at first as long as you show me what your points are and where the dots are supposed to be. We have one period of 12 sine of 2x plus 1. Okay? We're going to stop it here. I'm going to give you one to practice on your own, and then I'll show you the answer to it in a second and see if you got it right. So the next one I want you to do, I want you to graph one period of y equals 3 sine of 4x minus 5. Go through those same steps, sketch one period, and then I'll see you on the next slide. Moving on.